Good morning, guys. Hope you're doing well. Today I'm using my phone to record because I want to show you how to use something on the graphing calculator. So what we're doing is fitting linear models onto data, and this is going to be the last lesson in this unit. So expect your unit test around Thursday or Friday latest. Alright, so if we have data that's been graphed on a XY plane, we can use a linear model. So this data has been randomly collected and has been graphed as a scatter plot, and we can use a linear model or a polynomial model or anything else to determine whether this data is linear, constant, or linear decreasing, linear increasing, or constant. Now if you look at this, I hope you can see that this is linear, and something about this data tells you that it's decreasing because this one is modeling the number of hours of exercise versus the months the machine was on. As you can see that as the months the machine was on increase, the exercise done is decreasing. As you can see, this person owns the machine for about a month. They do 10 hours of exercise. This person owns the machine for around 10 months, and they only do 3 hours of exercise. So just by looking at this, I hope you can see that this data has a decreasing kind of trend or correlation. So we can use a line of best fit, which is what I just drew, to determine the relationship between the data and be able to extrapolate or interpolate. For example, if this data is only showing me from 0 to 10 months, but what if I wanted to know what happens when someone owns the machine for 2 years? How many hours or minutes or seconds of exercise do they have? I can use a linear model like this, which can be extrapolated beyond the limits of the data, beyond the domain of the data. Or I can use this same linear relation to interpolate. Interpolate is to find a value in the domain that's not part of the given plots. So all these plotted points are already part of the domain, but if I want to find say how many hours of exercise does someone who has it for 0.5 months do, then that's already within the domain of the data. Or even something like 6.2, since it's not given, I can interpolate using the linear function. And interpolating and extrapolation is simply substituting for a known value of either x or y, and then finding the unknown value of, again, either x or y. So in this example, two lines could be drawn, because if you're drawing a line of best fit, you're trying to draw a line that leaves around equal number of points on either side of the line. That's kind of going through the middle of the lines. If you look at the green line, it has 3 points above it and 3 points below it, or 4 points, and the blue line has 3 points below and 4 points above. So those two lines could each be drawn to represent the line of best fit. Once you draw the line of best fit, you find the slope of that line of best fit, which since we have plotted points, we can use the plotted points to find the slopes of either of these lines. Now the slope of line 1 is -1, and therefore its equation is y is equal to -x plus 12, and the slope of line 2, same thing, -1, and its equation is y is -x plus 12. So I hope that tells you that as long, either whichever line you choose, as long as you have chosen it correctly, meaning you have equal number of points on either side of the line. Like in this one, you have 1, 2, 3 for the green line points on above the line, and then you have 1, 2, 3, 4. Or for the blue line, it's the opposite. You have 1, 2, 3, and 1, 2, 3, 4 above the line. So as long as you've drawn your line of best fit correctly, then your equation should be a good model for the data. Now we can use these equations, or either of these, we can use the equations to determine, say, the value of y when x is 0.2 hours, or the value of x when y is 70 hours. 70 hours of exercise. Alright, so if we look at this one, if we want to determine whether it's linear or non-linear, Non-linear means either exponential or quadratic. So if I want to determine if it's linear, I'm going to ask myself, can I draw a line of best fit that kind of properly represents this data? And it's going to be hard for this one because the data is all over the place. So someone could argue that that is going to be the line of best fit, but that line doesn't show an increasing trend. Someone else could use this one, someone else could use this one, someone else could use a line like this. Sorry, that's supposed to be straight. A line like this, because you still have equal points above and below the axis. Even a line like this could work. Sorry, above and below the line, because you still have equal points. You could draw it that way and still have the same number of points above or below the line. So since this data is all over the place, let me just put these in different colors. You could draw it like that and have a point above or below the line. On either side of the line. You could draw it like that and still meet the same condition. You could draw it like that and still meet the condition. So this data is constant. It's mostly constant because, again, when you look at the change in y is changing from around 8 to 1, and x is also changing from 0 to 10. So that's going to be 1 divided by 10. Sorry, not 1. 8 divided by 10, which is 0.8. It's a small slope. So that is also another indicator that this data, a model that represents this data would be a constant model. So this data here is constant or non-linear. This one here is, what do you guys think? I hope you can see that it's nicely linear, right? And then this one, I hope you can see clearly that it's exponential, so that means it's not linear. Another one here, you can see it's almost looking like a quadratic equation, so it's not linear. So yeah, let's see how we can use our calculators to determine the linear, to draw a line of best fit, because these days calculators can draw the line of best fit for you. You don't have to stress, and then they can determine the equation for you, and then you even use the computers themselves to predict, extrapolate and interpolate information from your graph. So these instructions here, and I'm going to post this PDF on your Google Classroom. If we were using a physical calculator, the ones we have at school, but since we're using these ones on our phones, what you're going to do is, one, open your calculator, then click start. When you click start, it opens this. Click number 1, which is edit. When you click edit, it has list 1 and it has list 2. So just go below list 1 in the first cell and then start typing the data for example 3, which is the chirps in 15 seconds. So you start typing the data for chirps, you push the value and then you hit enter. So 44 enter, 35 enter, 20.4 enter, 33, 31, 35, 18.5, 37 and 26. Then you hit enter. Then you go to list 2 and do the same thing. 80.5, 70.5, 57, 66, 68, 72, 68, 72, 52, 73.5 and 53. After you're done with that, you can hit second function and then mod. Second function mod quits, because quit is above the second function. So then you go back to your blank screen. Now, since we're going to plot statistics, I hope you can see the start plot up here. And to activate that, I need to hit second function and then that button. So what I'm going to do here is, one, make sure that this is activated, that the graph is set to plot scatter, and also make sure that X is on L1 and Y is on L2. If it's not, just touch them to activate them. You can just touch them to activate them. So X is L1, Y is L2. The other thing you make sure of is that these other graphs, for example, hope you can see that y2, the plot 2, which would be the second plot, is currently on because I accidentally touched it, but click off to turn it off. So I'm going to click off, with that off. Then I'll make sure that all these other plots are also off. But I don't know if your calculator is letting you do many, which you only need one, so that's good. So the other thing to make sure of is that this color is not white, because I struggled a lot to figure out why my points were not appearing, because I had set the color to white. So just touch that and change the color to something. So I'll make mine red. Alright, since you've done that, again you're going to quit and go back to the blank screen, which you do by clicking second function and then mod, because it activates the quit. So second and mod. Now I have my data in, because I know I have my data here in start. You don't need to go, I'm just showing you that your data is still there. Quit. And now I need to find the, I'm going to do what is called linear regression to find a line of best fit and also find the correlation coefficient. To do that, I'm going to push start. Then I'll go to calc, which is the second function. Then I'll click number 3, which is linear regression. I hope you can see number 3 is linear regression. So I'll click 3, and then it will do the math for me and give you value data like this. So it says linear regression ax plus b. What that simply means is that this data is represented by a straight line whose equation is ax plus b, where the value of a is that 1 point something and the value of b is that. And I hope you remember that a is the slope, b is the y-intercept. Alright, so I've done that. I can hit enter so that my cursor comes down here. Now I want to see this data on a graph. If I want to see this data on a graph, I'm going to push Y, and then first make sure that there's no equation here, so you can clear them out. And then I'm going to type that equation. I'm going to type that equation because I know it's ax plus b, so a is right here, x is just here, and b is here. But to activate them, I need to use the alpha because they are the green functions. So I'll hit alpha a x, I'll just hit x, it types x, plus alpha b. When I'm done with that, I'll click graph. So when I graph, I will show me a graph that has my points and the line of best fit. So using this line of best fit and these plots, I can now, if I hit trace, the trace button which is down here, if I hit trace, I can move that dotted line. I hope you see it moving. I can move it up and down to determine value, like different things about this data. For example, if I want to know the x value when y is 50, I'll just move this until y is 50, and then it will tell me, because you can see y is 50, then it will tell me the x value. And then y is already 50, which really is 49.8. But yeah, if I want to know the y value when x is 50, I'll move x, the dotted line, to 50. Just slide it with your hand and then go up and read the y value, which is given here. So that's what you're going to be doing with this data. Now going back to our document, in this example we have plotted we've plotted the data. So I've showed you how to input all of this stuff. And okay, so the R value which you saw on the calculator, I hope you remember, so something called the R value. The R value in mathematics is what is called the correlation coefficient. Let's go back. That R value, in math we call it the correlation coefficient. R squared, we're not covering that in this course, but it's the square correlation coefficient. So correlation coefficient is simply the value that tells us how scattered or how skewed the data is. Let's see that further in the lesson notes. So R is the correlation coefficient, and if R is positive or greater than 0, it suggests an increasing relationship. If R is less than 0, it suggests a decreasing relationship or negative slope. If R is closer, the closer it is to 0, the more scattered the data is. So I hope you remember that example we saw where we couldn't really find a perfect line of best fit where you had so many things. That data was very scattered, and because of that, if you entered that data in your calculator, you can try it, you'll find that the R value will be very close to 0. So yeah, the closer it is to 1 or -1, the less scattered the data is. But the closer it is to 0, the more scattered the data is. Alright, so the equation, because remember the equation is y is equal to ax plus b, and the value of a and the value of b were given to you by your calculator. So you can just write the equation out the way you see on the screen here. These instructions here would work if we're using the physical calculators, but for the ones we're using on our phones, we don't need this part. Changing your window to featured data, that's just the zoom function on the calculator, because when it is graphed, I can zoom in or out. That's the good thing about this one, is I can zoom in or out to see my values clearer. You can even use this zoom standard, which would be super big, zoom start, would like put the graph on the screen size, so you can play around with all of these ones. But yeah, it's easier to zoom on this versus the physical calculator you would have been using if we were studying in person. So now we can use this graph, because this is the graph we have, we can use it to find information about this question. If I want to predict the temperature if there are 50 chirps in 15 seconds, so I know that the number of chirps is 50. I'll just go to my graph, slide that, click trace, slide it till I get to x value 50, and then read off the y value. Estimate the temperature if there are 50 chirps, so that's what you will do. So interpolation is when you predict a value that's inside the domain and range of the data, like I was telling you earlier. And extrapolation is when you predict a value that's outside the range and domain of the data. So as you can see here, if I found data inside here, which is within the range and domain of the given points, that would be interpolation. But if I found that value outside the range of the plotted points, that would be extrapolation. Alright, so just going back to the graph a little bit, how can I determine the temperature if there are 50 chirps? I know I told you this before, but I can go and click trace. When I click trace, I will move this line until I have x value 50. If x value is 50, you can get it as close as you want. Here, 50.0. Then I can see that my y value is 87. So yeah, that's fine. Or I can calculate. I can hit calculate on this one. If you hit calculate, which is right here, hope you can see that calculate button right there. If I hit calculate and substitute x value as 50, it will give me the y value automatically as 87 point something. That will be the most accurate one versus trying to slide it. If you have any questions on how to use this, please send me an email or a private message. This is going to be your homework. Have fun. Bye.